hopefully that comes out okay. All right. So I've got this, right? I've got to see if I can factor this, right? Now, in some other class you took, right? I know some of you learned to factor by grouping, right? Grouping requires 4 terms, and I said last time, grouping doesn't always work, right? How many terms do we have here? Did you ever learn a technique to factor 5 terms? Synthetic division, right? So that's the whole point. Synthetic division is applicable no matter how many terms you have, all right? Which is why we should probably just teach it from the beginning, right? Like just teach it from the beginning. That would probably be helpful. Okay, I'm gonna erase this. Here we go. I'm gonna try and factor. This is like some separate work I'm doing on the side here, all right? So what I'm trying to do is I'm trying to factor the piece that's inside. X to the 4th minus 9x cubed plus 17x squared plus 33x minus 90. That's what I'm trying to do, right? I'll get back to that in a minute. So what I do now is list all the different factors of 90 first, right? Shit. So I have a list here, the factors of 90. One end, 90. I'm giving myself plenty of room here. Those things, positive, negative 1, positive, positive, negative 1, positive, negative 90. Does 2 go into 90? 45 times. So 2 and 45, plus or minus. 3 and 30. Shit, I hope I don't run out of room here. 3 and 30. The only reason I do it like this, the only reason I do it that way is because I like my final list to be in order from smallest to largest. You don't have to. Some people just do like, okay, 1 and 90, right? And then they do 2 and 45. It's fine to do that as well, all right? This is just a convention that I've used over my lifetime of doing this. All right. What else?
9 and 10.
Yeah, so 4 doesn't work?
I don't know.
I think
4 doesn't work.
4?
22 points.
Yeah, so it's a fraction, so it doesn't work. It has to be, we're looking for integer factors. So 4 doesn't work. 5?
18.
18? So 5 and 18? 6? 7?
19.
6 goes. 6? I'm going to run out of room. If you weren't sure about that, you just use your calculator, right? Just sit there and just do 90 divided by 5, 90 divided by 6, right? 7, 8, 9. 9 goes, right? 9 and 10? Okay, sorry, I ran out of room. 9 and 10. And then I'm done, right? Because I kind of met in the middle. That's a lot of factors. Okay, now I need to make a second list. And that list comes from the number in front, right? The leading coefficient, and that's just 1. And that's the only factors of 1 are plus or minus 1. And I told you all last time, hopefully you remember, that whenever your second list right here is just this, then your final list is just your original list. Because what you're supposed to do to get a final list is do this divided by 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 this, all of them, right? Okay. Well, in this case, all of these numbers divided by 1 or negative 1 is the same list of numbers. So because of that, my final list is just this original one. We will do one where the list is worse, yes. Okay, and I have one for us here. Look at the last one, the last 2 there. Do you see the last 2? K and L. Do you see it has a 2 and a negative 5 in front? That means that we're going to have more than just 1 here. And our list is going to be huge. It's going to be nasty. But hey, you want to be able to factor this? This is what you got to do, all right? So once I've got my list, right, my final list here in red, what I'm going to do is start synthetic division. And what I mean is I'm going to draw an upside down division box. And I'm going to put the coefficients of this in this box. 1, negative 9, 17, 33, negative 90. Remember, leave a space underneath. And then you start going through these numbers with your synthetic division, and you're hoping that the last number at the very end turns out to be a what? a 0. And I recommend starting with the smallest number on the list and working your way through these. 1, -1, 2, -2, 3, -3, right? Work through the list. I promise you that if you work through your list from left to right, smallest to largest, I promise you that on the test, it's going to happen within the first 23 tries. No, I'm kidding. Within the first like 4 or 5 tries, it should work, okay? I'm not going to make it, where you have to do this 30 times to get to the answer. But you have to all follow from smallest to largest, okay? If you decide to start at the other end, I can't promise you anything, all right? With me?
Yeah.
Okay, so let's try 1. Okay, how does this work again? 1 drops straight down, right? 1 plus 1, 1 times 1, 1 divided by, what do I do here? 1 times 1 is 1, put it here. Add down. What's -9 plus 1? -8, okay. 1 times -8. -8, add down. In other words, 17, take away 8, 9. Okay, 1 times 9, 9, I don't think this is gonna work. Add down, 42. 1 times 42, 42. That doesn't work, right? It's not 0.
Try 5.
Try 5?
Just the one guess.
Is that the, I don't want to guess because I want to go through and I want to get to the first one that works, okay? Is it 5? I don't think it's 5. I think it's -2. It's -2 is the first one that should work. Okay, so would you all like me to show you that -1 doesn't work and 2 doesn't work? You want to see it? Yeah, I'm just gonna restart this. Okay, so I have to redo the division box. Let's see why -1 doesn't work. Let's see, -1 here. 1 comes down. -1 times 1 is -1. What happens this time when I add down? -10. -1 times -10 is +10. 27. -27. 6. Yeah, no way, right? -96, that's not working. You see, that didn't work. So now I move on to 2. 2. Start over. And on your piece of paper, when it doesn't work, just cross it out and do it again. Don't erase and try and do it over in the same place. 2, let's see, 2, 1 comes down. 2 times 1 is 2. -7. -14. 3. 6. 39. 60, 78, yeah. No, this doesn't work, right? See? Should work on the next one.
Yeah.
May I erase? Okay. -2 this time on the outside. Okay. -2 on the outside, 1 comes down. Okay, this times this is -2. Add down, you get -11. -2 times -11 is 22. This is 39. -78. 5, 45. -45. There it is, 90. And that gives me a 0 here. And that's what I want, right? That's what I want. So I didn't mention this yet, but this is actually pretty amazing if you think about it. The number that we have here, this -2, this number right here, 0, here's the connection. If I asked you to plug -2 into this right now, plug -2 in here, here, and here, guess what your answer would be? 0. What if I asked you to plug in 2, not -2? Your answer would be, do you remember whatever we got here? It wasn't 0, right? Whatever that answer was what you would get if you plugged 2 in. This is actually, you can use synthetic division to plug numbers into polynomials by just putting the number out here, doing synthetic. This answers what you get when you plug in. Instead of using your calculator and like doing 2 to the 4th and 2 cubed and screwing up all the signs, you could just do this. It's kind of a cool result of this. All right, I'm going off topic. I'm sorry?
It reminds me of a binary search algorithm.
Okay.
I mean, how it would work is that you would go.
It's okay. We can talk after class.
Yeah.
Yeah, okay. All right. Got it?
Got it.
Everyone clear? All right, so what this tells us is the important thing, right? And what I'm going to do is I'm going to take this result and I'm going to come back over here with it. What does the x minus 2 tell me? That I have a factor of what?
No, 2.
X. This right here is a 0 of the function,
Plus 2.
right? So that means x plus 2. So I'm going to come back over here. I know this was x squared, right? I know that I have x plus 2 now as a factor. You see that? But I have a bunch of crap still that I haven't factored. What is the crap that I have left? It's all of these numbers in front of x's, right? So what do I mean? This is a number by itself. This is the number in front of x. This is a number in front of x squared. And this is a number in front of x cubed. So I still have in here x cubed, 1x cubed minus 11x squared plus 39x minus 45. Understand? All we have done, all of that work, was just to get one more factor. And now what's in this parentheses, right here, must be factored. And which means we have to do synthetic division, right? The good news, yes?
Can you keep the zeros in different orders?
You can.
You can plug in like a different number and then you get like.
Yes, you could go one at a time. That's fine. Any questions? So I still have to factor this, don't I? Which means I have to do synthetic division. And I have to create a list, right? However, the beauty of this is that the list, you don't need to make a new one. All you have to do is continue with this list. All right? Continue with this list. So the way it works, the way that we wind up using synthetic division is, I already did this first step of synthetic division based on this, right? And these numbers are actually the coefficients here, aren't they? So what I'm going to do is from here, I'll do it in a different color, I'm going to create another synthetic division box below it. You see? And I'm going to just do synthetic division on this using the list that I have here. So what numbers should I use? We tried 1, it didn't work. We tried -1, it didn't work. We tried 2, it didn't work. -2 worked. What should I do next?
3.
You would think 3, right? Actually, you have to check -2 again. -2 could work twice, because what if this multiplicity is 2, right? Then you might have another x plus 2 in here. So you've got to check the x minus 2 one more time. All right, don't forget to do that. So let me try -2 again. 1, -2, it's not going to work. -13, 26, 50, 64, -1, 28. It doesn't work. Okay, it doesn't work. So if it doesn't work, what do I need to do? Move on to the next number, which would be 3, right? What am I working on? I'm working on this list. So I'm going to erase this, okay? Okay. Here we go. Here's my synthetic division box. I've got 1, -11, 39, -45. And now let's go to 3. Okay, I'm hoping for the best here. 1 comes down. 1 times 3 is 3. What's that? -8? -24? 15? Nope, not happening, right? Oh, wait. Oh, it does work. Hold on. 45. Hey. Yes. Yes. That worked. So now I know this number is a 0, which means x minus 3 is a factor, isn't it? So coming back over here, I know that this is x squared. I know I had x plus 2. Now I know x minus 3 is a factor. And then what's still here? What's still here? These numbers, right? From these numbers? It's a 15, then a -8x, and then a 1x squared. It's going to be a little quadratic, right? And now I've gotten it to a quadratic, which makes me happy because I should be able to factor this. I shouldn't need synthetic division, but if I needed to, I could, right? I could continue just doing synthetic division. But I'm hoping we're all to that point now where we can rewrite that as, let's see, two things. Let's see, I need to multiply to be 15 and add up to be -8. -5 and -3, right? We have completely factored it. And we notice something, we need to notice something, that you have a factor that appears twice, right? And that means it's that squared, which means we're going to have a multiplicity of 2 on that factor. So let me rewrite it. Okay, let me rewrite it. So that is x squared, x plus 2, doesn't matter what order I put this in, x minus 3 squared, and then x minus 5 equals 0. All right, we're almost done.
What causes the graph to bounce when it's squared?
What's that?
What causes the graph to
Let me draw it, and then we'll talk about it. I think once we have the picture, it'll make a little more sense. All right, so what do I do now? I've got it completely factored. I set each factor equal to 0, right? Set each of those equal to 0. So if you set that equal to 0, you get x is 0, right? If you set that to 0, you get x is -2, right? Not +2. And then if you set that to 0, you get x is 3, +3. You set that to 0, you get x is 5. These are my x-intercepts, right? One last thing before the graph, we need the multiplicities. So I look at the power on the factor. The power on this factor is 2. 2 is even. Even means I bounce, right? Here, power is 1. 1 is odd. Odd means I cross. Power is 2. That means at this x-intercept, I bounce. And then here, the power is 1, and so I cross, right? I think we should feel good about ourselves here. We can solve this equation. We just solved that equation. I think that's pretty good. Here comes the graph, right? The last step, step 3, sketch it. When you sketch it, you have to do it in the correct order, or else you can kind of mess things up. So what I do when I sketch it, this is step 3, is I just put all these x-intercepts on here, right? And I'm not real concerned about like the scale. I just want to make sure that they're in the right order. So -2 is over here. Let's see, 3 is over here somewhere, and 5 is over here. Okay? Now, the next thing I'm going to do is I'm going to go back to step 1. Step 1 was the end behavior, wasn't it? The end behavior. And it said both sides go up. So what you should do here, don't do this. Don't draw from this point up, okay? Because you don't know if you cross or bounce here. And if you bounce, then it'll be hard to draw it. It might look like a V. So I just say I'm going to go up over here, and over here I'm going to go up, right? That's what we had, up, up on both sides. And then I start to draw it. So from here, I'm just going to draw my little smooth curve polynomial, taking into account what I do at each of these. So what do I do at -2? Cross through. So I'm going to cross through the x-axis. Then I've got to come back up to 0, and when I get to 0, what am I going to do? Bounce off, and then I got to get back up to 3. When I get to 3, what am I doing at 3? Bouncing. And then when I go down, come back up. When I go to 5, I cross through and it'll connect, right? It should all connect together. So here we go. Cross, bounce, bounce, cross. There it is. So do we want to look at it? No, we don't really need to. We don't need to. But are there any questions? We're done with this problem. Any questions? I'm going to address the question about the bouncing, but is there anything else? Yes?
Whenever what would be a good way to draw the lines before you graph it? If it wasn't like up and up.
Well, what do you mean?
Like, let's say I had an even thing in even, if you had an even power degree and you had a coefficient that was also odd, how would I draw that? Or how would I go ahead and prepare myself?
If this was even and this was, well, we don't look, this number, we don't look at even and odd. We look at positive and negative. So if this would have been negative, then when I started my graph, I would have said it went down, down, right? Instead of up, up. And then when I draw it, I would cross through, I would bounce, I would bounce, I would cross. See, that would be the difference had this been a -1.
Okay.
Understand?
So it's just reflecting the process.
It would have been just a reflection. Exactly. Okay, can I address your question about the bouncing? So the question was, why is it that when it's even, it bounces? I think that's a great question because, just kind of weird, right? So I think maybe the best way I can illustrate it is let's not do the bouncing yet. Let's talk about where it crosses first. So right now, what we're saying is that, right here we cross, right? So if I were to pick a number to the left of this, let's say let's just say 4.9, right? 4.9, you with me? What would happen if I plugged 4.9 into this? 4.9 here, would it be positive or negative? That's fine.
Sorry, positive.
Positive, right? 4.9 here.
Positive.
Positive, right? I'm going to list this down. So when we plug in 4.9, we get a positive, then we get positive, then we get 4.9 squared, right, would be positive, and then 4.9 minus 5. Negative, right? Okay, what do all those multiply to be? Positive times positive times positive times negative. Negative, right? So do you see that at 4.9 we're below the x-axis? Yes? So I picked a number that would make this one right here negative, right? Now pick a point on the other side, 5.1. Does that have any impact on the first three? 5.1 squared, still positive. 5.1 plus 2, still positive. 5.1 take away 3, still positive. See, it doesn't have any impact on these three. But right here it would become what? Plus. Okay? So now you're above. You're above instead of below. And that's because if you take a number on one side of 5, it'll be negative, on the other side it'll be positive. Now, think about here. What if I pick a number here, like 2.9? Right? So if I pick 2.9, does it matter? Like 2.9 minus 3 would be negative, right? But I'm squaring it. So it's going to keep it positive. If I pick 3.1, the other side, it's going to be positive, right? So what's happening on both sides is the same thing because of the squaring. Does that help or no? So that's why you get the bouncing effect. What happens on this side happens on that side as well. Okay, I hope that helps. All right, you ready to do the next one? Yeah. Let's do the one that has a fraction, or not a fraction, that has the, why don't I leave J for you? Okay, why don't I'll leave J for you to do at home. Since only 5 of you got that quiz, why don't I offer this as, it won't replace the quiz grade, okay? But why don't I'll offer 5 as, you turn it in next time if you feel like you didn't do well on that quiz, all right? I'll do something with it. I'm not sure what, but J1. Yes? Yes, so I would turn that in if I were you. Yes. J1. Now we are going to do, and turn that in next class, please. If you want, you don't have to. If you don't want to do it, you don't have to. So, all right, I'm going to do K or L. Which one do you want? The ugliest one, or
I like K.
let's do the ugly one. L1 of x is negative 5 x to the 5th. Oh, x to the 4th. X to the 5th plus 26 x to the 4th minus 36x cubed minus 8x squared. What happens if you copy the problem down wrong? It's probably going to not work out, right? So be real careful when you copy it that you copy it right. All right, first step. I want to sketch this, right? First step, what's the degree? 5. What are we concerned about with degree?
If it's odd or even.
Even or odd? So this is odd, right?
Yes.
Odd. All right. So now we look at the leading coefficient. The leading coefficient is the number in front of that, negative 5. And there we're concerned with whether or not it's negative or positive, right? And in this case, it's negative. And when you have an odd degree and a negative leading coefficient going off the table that I gave you,
It's
up then down. Up on the left, down on the right. All right, second step. We got to set this big ugly thing to 0, x-intercepts. So should I go to synthetic division right now? Is that the first thing I'm going to do? Just jump to synthetic? No. Factor out a GCF if you can. Do we have a GCF? X. Don't forget that step, okay? Because you'll lose that. If you do that, I promise you, you'll lose that x-intercept. It'll disappear from your work. So pull the x out. Now negative 5x to the 4. God, I keep on messing that one up. X to the 4th plus 26x to the 3rd minus 36x squared minus 8x plus 32 equals 0. And now I'm going to go do my synthetic division. Shit, that's going to suck. All right? Right, so here I go. I'm getting ready to do my synthetic, right? But I got to get my list. So my list first comes from the number in the back. And remember, I'm not looking at this x, just what's in that parentheses. So the number in the back is 32. All the factors of 32. 1 and 32. 2 and 16. 3. No, 4. 4 and 8. 5. 6. 7, 8. Okay, so 8, that's it. Then I have to make a list from all the factors of negative, or the sign doesn't matter, just use 5. And what are the factors there? 1 and 5. And that's it, 1 and 5. So this is the first time that we've had 2 numbers in this list, right? Up to this point, it's always been just 1. And because of that, we need to get a final list. And that final list is going to be every number here over 1, and then every number here over 5. Okay, so let me start doing that. This over this, this over this, this. So all of those over 1 is that list up there, right? That is just that original list. Right? That's the original list. That's all of those divided by 1. Now, I have to do all of these divided by 5. So what's 1 divided by 5? 1/5, and we do both the plus and the minus of 1/5. Then 2 over 5. So we have plus or minus 2/5. Then we have what? plus or minus 4/5. Yes, these are fractions. Then 8/5, right? Then 16/5, and then 32/5. Yes, it is possible to plug fractions into synthetic division boxes. All right? It is something that can be done. All right? Okay. Well, where do I start? Well, I'm making you a promise that on the test, it will happen within the first few tries, and I'm also going to promise you that a whole number is going to work, okay? That way you're not going to be concerned about the fractions. All right, so the first whole number that works is 2. All right, I'm not going to go through the others. Imagine I try 1, it doesn't work, -1 doesn't work, okay? So let's try 2. Is that all right if I don't show those? Sure? Everyone's all right with that? What's in my synthetic division box? What's the numbers in here? What are the numbers? -5, 26, -36, -8, +32. Okay, so 1 doesn't work, -1 doesn't work. I'm pretty sure 2 does. So drop your 5. See, we're dropping 5 now, not a 1. I'm sorry, -5. We're dropping -5 down. 2 times -5 is -10. Add that down, we get 16, 32, -4, -8, add down -16, and then -32, and then 0. Again, this means that when you plug 2 into that, you get 0, right? Which means that that is a 0 of the function, which means this now can be written as x. And then what's here? -2, right? And then the remaining piece is -5. Let me see. What is this going to be? We have a number in front of x, a number in front of x squared, a number in front of x cubed. That's the part that was confusing you? Okay, yeah. Another way you can think about it, if you want, is that whatever's left over here, okay, whatever's left over is 1 degree less than what it started as. So if it started as x to the 4th, this is going to be x cubed. If that started as x cubed, this will be x squared. Okay? Question?
So is it like a template? So is it like a template for you to fill in numbers?
Is it a template? Is what a template?
Like what you have left over?
Yes, these numbers are a template. I guess you can say a template for the next synthetic we're going to do. Is that what you mean? Yeah, these numbers are going to be what we're going to use for the next synthetic. And what we need to do is we need to see if we can